Buoyancy. When an object is placed in a liquid, the liquid exerts an upward force on it. If a piece of cork is held below the surface of water by applying the force of our thumb and then released, the cork immediately rises to the surface. It appears as if some upward force is exerted by water on the cork, which pushes it to the surface. Not only water, but every liquid exerts an upward force on the objects immersed in it. The tendency of a liquid to exert an upward force on an object placed in it is called buoyancy, and the upward force acting on an object immersed in a liquid is called buoyant force. The upward force exerted by a liquid is also known as upthrust. Magnitude of buoyant force. The magnitude of buoyant force on an object can be found out by a simple experiment. Let us suspend a metal cylinder from a spring balance and take its weight in air. Its actual weight, say 150 gram. Now let us lower the cylinder attached to the spring balance in a container of water in such a way that only a small volume of the cylinder is immersed in water. The reading on spring balance will decrease to 140 grams, showing that when a small part of the cylinder is immersed in water, its weight appears to decrease and it becomes lighter. Let us now lower the cylinder further down in water so that a large volume of cylinder is immersed in water. The reading on spring balance will decrease further, becoming 130 grams, showing that when a large volume of cylinder is dipped in water, its weight decreases further and it becomes more lighter in water. Again, we will lower the cylinder further to immerse it fully in water. The reading on spring balance will decrease again to 120 grams, showing that when the cylinder is fully immersed in water, its weight decreases further and it becomes still more lighter in water. If we lower the cylinder further, its weight will not decrease anymore. Thus, the maximum loss in weight of cylinder on fully immersing in water is 150 minus 120 is equal to 30 grams. As more and more volume of the object is immersed in a liquid, the upward buoyant force acting on it increases. But once the object is completely immersed in a liquid, then lowering it further in the liquid does not increase the buoyant force. This means that the maximum upward buoyant force acts on an object when it is completely immersed in the liquid, and the maximum loss in weight of an object takes place when it is fully immersed in a liquid. Factors affecting buoyant force. The magnitude of buoyant force acting on an object immersed in a liquid depends on volume of object immersed in the liquid. As the volume of solid object immersed inside the liquid increases, the upward buoyant force also increases, and when the object is completely immersed in the liquid, the buoyant force becomes the maximum and remains constant. If we fully immerse two balls made of different metals having different weights but equal volumes in a liquid, they will experience an equal upward buoyant force. This is because both the balls displace equal weight of the liquid due to their equal volumes. It shows that the magnitude of buoyant force acting on a solid object does not depend on the nature of the solid object, but it depends only on its volume. The buoyant force exerted by a liquid also depends on the density of the liquid in which the object is immersed. The liquid having higher density exerts more upward buoyant force on an object than another lesser dense liquid. Thus, as the density of liquid increases, the buoyant force exerted by it also increases. The seawater has higher density than fresh water. Therefore, it exerts more buoyant force on an object immersed in it than the fresh water. That is why it is easier to swim in seawater than fresh water.